Okay, let's take a look at solving a system of linear equations using elimination with multiplication and addition. So here we're still trying to use the elimination method, but it's not going to be quite so easy. Now, just as a quick review, the elimination method, the whole goal is to add the two equations to eliminate one of the variables. Now, in order to do that, we need to get one of the variables, either x or y, get one variable with opposite coefficients. Like, for example, I want to get like 2x and negative 2x, or like 5y and negative 5y, or like, I don't know, negative 7x and positive 7x. You get the idea. I want to be able to add them up so they make 0 x's or 0 y's, whatever that is. So that's the goal. If you take a look at example 1 here, which please do write down if you haven't yet, we need to be able to like get to add these up and cancel out the x's or the y's. Now right now, negative 7 plus negative 3 is negative 10x. That's not going to cancel. And 6y minus 2y would be 4y. That's not going to cancel. So I'm kind of stuck. I need to think about how I can make these numbers into opposites. So like what I like to do is I'll look at, for instance, I'm going to focus on x just for a second. It would be nice if I can have these both be like 3 and negative 3 or 7 and negative 7. It's always easier to make the smaller number into the bigger number if possible. So like if I could change 3 into a 7 by multiplying by something, not just adding something or subtracting something, that's what I'm going to need to do. So it's not easy to make 3 into a 7 because 7's not a multiple of 3. So I'm going to maybe skip on the x's. It's not easy to turn the 3 into a 7. So I'm going to look over at the y's and see if I can get a little easier time here. Now, I'm looking at 6 and negative 2, and again, focus on the smaller number, which happens to be down here, negative 2. I'd like that if instead of being negative 2, it would be negative 6. Like 6 plus negative 6 would cancel. And I know that negative 6 is a multiple of negative 2. All I'd have to do is multiply negative 2 by 3 to make it negative 6. So what I'm going to do is I'm going to multiply this entire bottom equation by a positive 3. Right? I'm not doing a negative 3 because I know 3 times negative 2 is going to stay negative 6 to add with a positive 6 to cancel. So the goal is to get opposite coefficients, and I know I got 6 and negative 6 in my target for y, and I'm going to make that happen by multiplying the bottom one by a 3. Now, I'm going to copy down that top equation, which was negative 7x plus 6y equal negative 11. I'm going to multiply everything in the bottom by negative 3 to make it, let's see, 3 times negative 3x would be now negative 9x. 3 times negative 2y will be negative 6y. And 3 times negative 23 is going to stay negative, I think that's 69. Now let's add this stuff up. Negative 7 minus 9, that's negative 16 x's. These cancel out when you add them. That's what we wanted. If that doesn't cancel out, you got to go back to the drawing board. You didn't multiply by the right number. And let's see, negative 11 minus 69, that's negative 80. And so we have to divide by negative 16. So I'm going to have a positive value. What is that? I think that's 5. 5 times 10 is 50. 5 times 6 is 30. 50 and 30 make 80. That sounds right. So I get x is 5. Now I'm going to back substitute x is 5 into one of my original equations. I'm just going to substitute that into the top equation. By doing that, I'm going to get negative 7 times the x value we just found. That's 5. Plus 6 times the y value should be negative 11. That's going to be negative 35 plus 6y equals negative 11. If I add 35 to both sides, I get 6y equals 35 take away 11. What's that? 24, positive 24. And if I divide by 6, I get the y value is 4. So I have my y, I have my x. We are all finished here. So I hope this helps you get an idea of how we can solve a system of linear equations with elimination and multiplication with addition. Thanks for watching.